The metadata is maintained in the memory as well as on the disk. On the disk, it is kept in two parts, Namenode image and edit logs. The namespace image is created on demand, while edit logs are created whenever there is a change in the metadata. So at any point of time, to get the current state of metadata, edit logs need to be applied on the image. Writing it to the disk on every change may be time consuming. Without the name node, the HDFS cannot be used at all. This is because we do not know which files are stored in which data nodes. Therefore, it is very important to make the name node resilient to failures. Hadoop provides various approaches to safeguard the name node. The first approach is to maintain a copy of metadata on NFS, Network File System. Hadoop can be configured to do this. These modifications to the metadata happen either both on NFS and locally or nowhere. In the second approach to make the name node resilient, we run a secondary name node on a different machine. The main role of secondary name node is to periodically merge the name node image with edit logs to prevent edit logs from becoming too large. When a name node fails, we have to first prepare the latest namespace image and then bring up the secondary name node. This approach is not good for production application, as there will be a downtime until the secondary name node is brought online. With this method, the name node is not highly available. To make the name node resilient, Hadoop 2.0 added support for high availability. This is done using multiple name nodes and Zookeeper. Of these name nodes, one is active and rest are standby name nodes. The standby name nodes are exact replicas of active name node. The data nodes send block reports to both the active and the standby name nodes to keep all name nodes updated at any point of time. If the active name node fails, a standby can take over very quickly because it has the latest state of metadata. Zookeeper helps in switching between the active and the standby name nodes. The name node maintains the reference to every file and block in the memory. If we have too many files or folders in HDFS, the metadata could be huge. Therefore, the memory of name node may become insufficient. To solve this problem, HDFS Federation was introduced in Hadoop 2.0. In HDFS Federation, we have multiple name nodes containing parts of metadata. The metadata, which is the information about files and folders, gets distributed manually in different name nodes. This distribution is done by maintaining a mapping between folders and name nodes. This is known as mount tables. In this diagram, the mount table is defining /mydata1 folder is in name node 1 and /mydata2 and /mydata3 are in name node 2. Mount table is not a service. It is a file kept along with and referred from the HDFS configuration file. The client reads mount table to find out which folders belong to which name node. It routes the request to read or write a file to the name node corresponding to the file's parent folder. The same pool of data nodes is used for storing data from all name nodes. Let us discuss what is metadata. Following attributes get stored in metadata: list of files, list of blocks from each file, list of data nodes for each block, file attributes, example, access time, replication factor, file size, file name, and directory name. Transaction logs or edit logs store file creation and file deletion timestamps.